Well, Ethan, and
All right.
thanks.
So today I'm gonna talk about this demo I made uh, with vacuuming in Roblox, and then we're going to code a new vacuuming effect. Uh, Should be cool. And so first, I'll show you the video. The same video that Dan posted on Twitter. I'll show you the video first because then I'll show it. I'll show you what it looks like in Studio, and you'll kind of be less impressed. But here's how it used to look back when I made it in March. Okay. And now I'll show you how it looks in Studio.
Why is it less impressive?
Oh, okay. So do you see these like popping out these
Sure.
lines? Yeah. So I think to any Roblox developer who's been around for a while, when they see an effect that they don't understand, they go through a checklist of like, is it glass? Is it viewport frames? Is it bones? That's
Right.
like it's usually one of those three.
I didn't get the.
Uh,
I don't get what bones are though. The other two, I guess, I understand.
oh yeah, we'll actually use bones later
But
on
okay,
today.
sure.
Yeah, so of those three options, this one uses glass. And the effect here with glass is that, let me pick up this guy. So when you have a glass part whose transparency is really high but not one, and you have a part behind it whose transparency is really low but not zero, then the part in front, the glass part, like occludes it. And so that's the effect. And so it's unfortunate, I guess, it doesn't work as well anymore. It worked perfectly fine back in March, but maybe they adjusted like like at what number you need the transparency to be set at. So maybe I just have to fiddle around with it.
So just to be clear, there's hundreds of these circles, these glass
Right.
circles that are laid down.
Yeah. So here is how. No, that's not it. That's how it looks.
Mm-hmm.
Yeah. So I guess I'll actually show you how that works. So right. So as I walk around, new glass circles are placed, and there's also rectangles between them. So I'll slow down the effect a bit. So once I move a certain amount of studs, then it places a new circle. And then there's always one that's locked beneath my feet.
So the thing with the circles appearing and disappearing now is just something to do with the rendering engine or something.
Yeah, you could say it's a bug, but the fact that this happens is a bug, so maybe it's kind of fixed. Although from a developer's perspective, we don't want that. It's kind of funny. I think Arsney might be quoted as saying something to the effect of like, one day we're going to fix this, and when we do, we'll have no remorse. Because they said from the very start to not abuse this effect, and we've been abusing it for 5 years.
Do
Okay,
you think they
so
might like introduce like a way to do it in an in an intentional way, like a sort of occluding part or something?
I would hope so. Yeah, I would hope that they would provide an official API for that effect. Okay, so uh, that was that. Now, the way this came about, um, usually when I have a new idea, like this happened recently with the voxelizer that I was posting about. Usually I'll like have a vision in my head of just some cool effect, and so I'll like scramble to make some demo in a couple hours. And what tends to happen is I just want to make something that looks cool. And then I end up having to do some like challenging mathematics that I did not foresee. And I think this demo has some cool things about it too. So there's some questions you might start to ask. Sorry, let me actually reset this to its original state. When I walk around, look at these particles here. These particles, all I'm doing is creating parts around like the semicircle in front of me and then moving them with a force towards my body. So it looks okay until, say, somewhere like this, where that doesn't really make any sense of where the particles are coming from. Or if right, like now I'm touching part of the boundary, so we should have some particles, but not all. So the question here is, how do we determine where the boundary is to spawn the particles? So I think that's an interesting question. Another thing to think about is, how do we calculate the percent of the dirt that we've vacuumed? So like if we were to turn this into a game, suppose the game is like you have 5 minutes to vacuum up the floor or whatever, and oh wait, that wouldn't make sense. Right, so if the game to just vacuum up the entire floor, how do you calculate the percent? Another thing is, how could we accomplish this effect without glass? How could we somehow create this dirt mesh ourselves? And then the last thing that I think was interesting about this is, what if instead of like faking the effect, what if we actually just simulated particles? And so here's somebody who's actually done that. Right.
Is this on Roblox or something else?
That was Unity. That was this guy Sebastian. He makes some really cool game development videos.
So
Yeah.
is
So
that
those are. Oh,
possible,
sorry. Go on.
or any fundamental reason why that's not possible to do in Roblox and it is in Unity, or what?
At least for the particle simulation thing, I think it would just be speed. I'm sure if you I'm sure it's possible.
Like, does
Maybe
Unity have like a specific like sort of particle simulation sort of entity?
I have no idea. Um, Maybe you're like closer to the GPU with Unity. Okay, so those are a few things I had in mind when I was making this. And I think if I were to make this into a game, I think that's a pretty good direction to take. And I would say, if you can solve these problems, then you have my blessings to make a game out of it. But I want the royalties. I'll take the premium payouts. But yeah, I think those are some interesting problems to think about. However, I instead want to take it in a different direction today. So the first option is kind of the one that it's already set up for, which is something that I would call like, so option one being like a mobile puzzle game. Mobile as in like your phone. So an example of this would be like Angry Birds, Candy Crush, where they're the type of game where you complete puzzles and they increase in difficulty, and then like at the end it says you win, and then you get some like stars, and so if you complete it in a certain amount of time, you get like 1, 2, or 3 stars. So I think it's like that's a natural direction to take the game. um Second option, which I think is a little bit cooler, is something like a simulator. Now I think I've been on Roblox for far too long. The fact that this is where my brain goes is to make a simulator type game. But the idea here, so there's like a few main aspects, core components of a simulator. Usually you have some kind of thing that you're collecting. So in this case, you're like vacuuming up objects, and then there's a thing that you're collecting with, which would be the vacuum, and then you have a backpack to hold the things that you collect. And so this, I guess you call it like the canister. I don't know. Yeah. So that's a simulator, and so maybe you start out like main difference between the mobile game, the simulator, and the mobile game is like you're always vacuuming the dirt. Where the simulator, maybe you start out with the dirt, but then you upgrade your vacuum, and so maybe something a little bit larger, like a marble, and then something a little larger, like an apple. Okay, and so then we can keep doing this, and maybe eventually you can vacuum up a couch or a house, and then I don't know, you can vacuum up the Earth and I don't know, galaxies.
There's like a game with a guy that has like a sideways cylinder for a head. He's green. He like rolls a ball around. Do you know? Do you know what I'm talking about? I forget the name.
No. Sorry, say it again.
Uh, I, I'll find it. And then
Okay. But yeah, so I thought that this mechanic of like being able to vacuum up larger and larger objects, that seemed a bit more interesting to me. And you don't actually have to make it into a simulator. I don't think I ever would, but just I think this is a bit cooler. And so the effect that we're going to make today is something along these lines.
Have you ever played Luigi's Mansion?
Yeah, okay. So
So
I was
great.
pitching this idea to somebody, and then they were like, "Oh, so you're making Luigi's Mansion?" It's like, what is that? I had not heard of it.
Yeah, it's a fantastic game. So it's Luigi's version of a Mario game, except Luigi's a complete coward, and he's basically just trying to survive in some haunted mansion. And he has a vacuum on his back, which he uses in principle to suck up the ghosts. But the main attraction of Luigi's Mansion is that you walk around this environment, often a large mansion, and you just wreck it. So you suck the tablecloths off the table and everything falls off. You suck up all the cutlery. You open the wardrobe. You suck out all the clothes. You just kind of walk around this room, and by the time you're finished with it, it's bare and completely barren of anything. So you're like this terrible menace with a vacuum. It's great.
Right. Yeah. So the friend who told me that, then he showed me the game a little bit, and so the effect that we're gonna make today is actually inspired by something I saw in the game. Okay, and I guess I may as well get into that. So what I was looking at when I made the game was like the way that the ghosts get sucked into the vacuum. Let me move. Sorry, I'm moving on my iPad real quick. Okay, so let's suppose we have like a couch or something. Okay, so oh god, I should have picked something simpler. All right, so there's your couch, and there's your vacuum, right? And then what's going to happen is the couch is going to like get sucked in, and it's going to get like smushed in. So let's see, something like this. Okay. Uh, that's awful. Maybe, okay, let me, so suppose we're sucking up this cube. What the cube is going to look like is it's going to kind of get funneled in to the vacuum. And so that's what I want to create. And that's what we'll be using bones for. Okay, so if you haven't seen bones, uh, let me open up a file. Right. The windowing is broken. Okay, I first have to close this.
It's become so bad.
I hate it. Yeah, I hate owning a studio now. Okay, here's a cube that I rigged beforehand. So these blue things are bones, and then I can drag these bones individually to influence the mesh. And so what my thinking is that we simulate the bones as particles, and we apply forces to the bones such that they get sucked toward the vacuum, and they make that like funnel shape into the vacuum. All right. So we already have this cube rigged, but I actually want to show you all how I did this, because the documentation on it isn't great. There's some YouTube videos on it, but they're also kind of hard to follow. So I want to do that real quick just to have on recording like evidence of how this is done. Because I learned this recently. Actually, when we did our game jam, I was trying to figure this out. I could not figure it out because I wanted nice bending roads, and now I think I could do it. So let me show you how this works. So I'm really not good at Blender. Everything I know how to do in Blender is from just playing around, messing things up. So hopefully I can get this on the first try. So we're gonna start with this cube, and first we're gonna need some more geometry, because you'll notice that with this cube I can pull out this vertex, and well, there's some extra faces here that aren't on our cube currently. So I'm gonna go to edit mode, which is also tab, and I'm going to create loop cuts. So loop cuts, you can click this button here, or you can press Control R. So here's a loop cut, and I can use my scroll wheel to add more loops. So we'll just have one loop, and I'm going to click, and then it's going to want to drag the loop cut with my mouse. But if you right click, then it goes away. So we've added some new faces here, and then we'll create another loop cut here. Right click, and then one more loop cut. Okay, and then I'm going to hit tab again to get out of edit mode. So we've added our faces, and now we want to create our bones. So to create bones, we're going to go here to add armature. And again, I'm going to go to edit mode. And we can't see our armature, so we're going to go to one of these down here. All right, viewport display. We're going to display it in front so that we can just see what we're working with. And this is a bone. So this what you're seeing here, the bottom of this is one of these blue dots. So we don't see what the top is, but we see the bottom. And if I extrude a bone, so if I press E, then I create a new one, and you can see that these bones are connected. So the case where you'd want connected bones is something like a character's skeleton, where the elbow connects to the shoulder and the elbow then connects to the hand, and I don't know, the shoulder connects to the torso, like that. So you'd want all of your bones connected, because when your bones are connected, then bones higher up in the tree affect bones lower down in the tree, so that if you say move your shoulder, then it also affects the rest of the arm. So if you had a skeleton, you'd want something like this where all of your bones are connected. But if you want something like what we have here, where I can drag these bones separately and they don't affect the other bones, then we're just going to want individual bones. And so I'm going to add a new one with add single bone, and you can't see it, but so let me drag it. Drag is G, and then I'm going to press no, okay, I'm going to how am I going to do this?
Is the bottom of the bone supposed to be centered in the cube, or is it just centered in the origin, or what?
Yeah, what you're seeing is it's in the origin.
Okay.
Probably what it did is it selected it, or it created it by this red circle down there, which is my 3D cursor.
Mm-hmm.
Yeah, so I'm going to move this with G. I'm going to press either Z, X, or Y to move it along a particular direction. So there I press Y. And then I'm going to hold Control, so that it snaps to the grid. So I moved it. Oh,
You can also just press a number, I believe, and it'll move it exactly that distance.
I actually, oh, wait, can you? So if I do X and then 1, oh, thank you. Like I said, I'm very new to this. But yeah, so this
That's
is,
the one thing I know.
right, and then copy a bone is Shift D for duplicate, and then I'm going to, it's one of the axes. Okay, so I won't make you sit through me creating all of this, but here's the idea. So we have these bones. Hopefully this works if I don't have all of them. All right, so now we're going to get out of edit mode.
Do you have a point in any particular direction, or like what's the significance of the other end of the bone?
I mean, I think it probably matters when you have bones connected to each other. But for these one-off bones, I don't think it does.
All right.
Actually, this isn't too hard to finish up. So I can just make a layer and then copy it. Okay. Uh-oh. What have I done? Okay, I'm going to stop there before I screw up anything more. Okay, so we're going to get out of edit mode, go to object mode again. So first, the way that we combine the armature with the cube is we're first going to select the cube, then we're going to shift click the armature, and then control P. Control P parents the armature to the cube. We're going to select with automatic weights. So let's see what that got us. So now we can go into pose mode. We can select one of these. We'll press G to move it, and then we can see that it influences our cube. That looks pretty good. But you'll notice here that I have these set up so that it has, like, moving one vertex has no other influence on any other vertex. Whereas if I move this, it kind of drags along a lot of the cube with it. Now, I don't know, maybe this might be desirable. We haven't actually coded the thing yet, so maybe this is what we want. But at least for the sake of example, I'll show you how weight painting works. And so weight painting is how we determine, is how we tell it which vertices a bone influences and by how much. So to get to weight painting, we're going to, oh, how are we doing this? I'm expecting to see something over here. Okay, that's right. Right. Okay, so here are what our weights look like. So, all right, so I'll select bone 1. Which bone is bone 1? I guess we should also have them show names. Okay, maybe it's too late. I don't know how to do that. Presumably this one down here in the corner is bone 1, and this is the weighting of bone 1. So when it's red, that means that it has more of an influence on that vertex, whereas these greens has less of an influence, and blue has no influence. And we can do what's called weight painting by just dragging around our mouse, and we can paint the vertices that it has influence on. And so the way that I've gotten these to only influence one vertex is to weight paint them such that, so here I'll paint 0 weight to get rid of stuff. Okay, and so I've painted them such that they only influence one vertex. The red is just concentrated on one. And so now if we go to, we want to go to pose mode. All right, we should be able to drag this and see that it, okay, that didn't have the effect I wanted it to have. Maybe I've done something wrong. Anyway, that's weight painting. The whole point of this, I feel like, I don't want this to become a Blender tutorial, but the point is that maybe now when you go to do this yourself, you'll be a little less intimidated, and maybe you'll know kind of what to do. So the last step in our process is we want to import this into Roblox. So we'll select our part and we'll select our armature, and then we'll go to export as FBX. And I've had to fiddle with this a bunch. So here's what I found to be the best option. So we want to limit our select to the selected objects. We want our scale to be 0.01, meaning it takes 100 studs, meaning right 1 meter in Blender is 100 studs in Roblox. And then we export as FBX. And now the way to import this is kind of unintuitive, but we're going to go to plugin, and then we're going to find avatar importer, which is weird because it's not an avatar. But then we're going to go to custom. Where did I put it?
Why do that rather than the standard model importing?
Oh, because with this way you can import the bones.
I see.
Right. And so here's our bones, and we can drag them around, and this is what we expect to happen. Wow, that's awful. Okay. Okay, so that's the game plan. We're going to somehow apply physics to these bones such that it goes into our vacuum as desired. Now, at the beginning, I said that I said to join TRS to contribute. The intention being that if you have a better idea, then I would like to hear. Because this is, yeah.
A better idea for like the vacuuming effect.
Yeah.
In terms, because I was thinking like, if it doesn't have to like change instantaneously, can you just sort of like scan just scan the perimeter of the circle around you and just see if there's like glass there or not, and then you sort of know the sections of like of sand, and then like you can just do the particle effect you already have, or the parts you already have, just in those sections of the circle around you, and you just like sort of update that every like half a second or something.
Oh, so okay, maybe I should clarify. What I mean is what we're trying to make is what I've shown here of like a couch getting sucked into a vacuum.
Oh, right. Sorry. I thought you were talking about the sand thing.
I'm trying to think what the Luigi's Mansion thing looks like, but I think it does probably look like what you're describing. I don't know how they actually do it, but it's clearly not just rotating and resizing the objects. It's, I think it is deforming them.
I studied the footage a little bit. It looks like, I think the objects, they just get smaller, scaled down, but the ghosts at least, which is where I got the idea from, like the tail of the ghost kind of looks like what we want, of like shrinking towards the tube.
Right, I guess they were careful to have this interesting effect mostly on things like ghosts or fabric that is easy to deform. Yeah.
Also, what's cool, maybe, okay, I won't like, actually, I've searched Spraver things live before. Oh, I couldn't get Dolly to like make a good image. I was just gonna search up the Luigi's Mansion thing because they have this like visible effect where okay, I'm just gonna shut up and look for it. So what I'm trying to show is you'll see like, okay, that thing, the cone that comes out of his vacuum. I think that's kind of cool. And it bends too. It's not just a cone. But maybe this isn't a good example. Anyway, I think that would be cool to make too. But at least for what we're making today, so suppose we have this these bones here, and we have the end of our vacuum here. Let's look at the forces on just one bone. So we want to have a force that points to the vacuum. There we go. Points to the vacuum. But we want it. But if we only do this, then I think we kind of just get like a uniform scaling effect. And okay, so maybe the force should be proportional to like the distance squared or something, so that it acts more on the nearer particles. But to get that force or the funnel kind of look, maybe we take the direction that the vacuum is pointing, something like this, and then we break down F into its components of one component pointing toward that vector, and then one like that, like parallel. And so maybe and then maybe that vector is like stronger, so that the path of the particle follows something like that. That's kind of what I'm thinking.
Yeah, sounds reasonable to me.
Okay. All right, then I guess we'll get cracking. An important thing to note about when you're using bones is that skinned parts always have to be inside of a model. There was a panicked moment I had in the MetaUni dev chat where suddenly TRS got very slow to load with the new tubes, and that's because the tubes were not in a model, they were in a folder. So something to keep in mind. All right, so this is the part that we want to go toward. And this is, I don't know what that is. All right, let's make a new script. And certainly we're going to need run service for this. We're probably going to want to do something unstepped. And we're probably also going to want all of the bones. Is that bone? Yeah, that's okay. That's cool. And oh, okay. So one thing to note about this, you can't like apply constraints to bones. I've tried. It's there's a forum post saying that they want to make this possible, but at present you can't. So what we're actually gonna have to do is simulate parts and then attach the bones to the parts. And by attach, I mean manually set the C frame every frame. Now this used to be an issue, this manually C framing bones. Like if you had, say, hundreds of bones, that used to be an issue. But apparently they're much faster now. It also used to be an issue of having static bones. Like even if you're not doing anything with them, they would still have a performance cost, but now there's none, which is how we have so many tubes in TRS. Okay, so we're also going to want to create parts per bone. So maybe we'll do this. Actually, I could probably steal some code here. What was I doing? Sure, that's fine. Okay, and we'll associate with each bone its part, except this name doesn't really make sense. Sure. And let's see, we don't want it to be anchored. And oh, I remember what I was doing here. I was trying something similar, but when the part isn't being sucked up by the vacuum, what we wanted to do is stay put. So we're probably going to want to like have it on a spring and then make sure that it's the spring is attached to some static part. So let's also create a part for that, and then we'll connect them with a spring, or maybe not a spring. I'm not sure what we'll use yet. And this one should be anchored. And then what are we going to use? So sure, I guess we'll start with a spring and see how that goes. Oh, we're also going to need attachments if we're going to use constraints. And let's see, so the parent, and then we're also going to need the attachment 0. Attachment 1. Okay, let's see how that works. And then what are we going to keep track of? So we're going to need, probably going to need, all right, I won't be a caveman. I'll make this a dictionary. All right, and then we're also going to need a vector force. Looking for, what is this enum? Actuator relative to. Okay, and so this is going to be the force that we're going to use to attract it to the vacuum. All right, let's do that. What happens if I play this? Oh, all right, I did not give them a C-frame. So the way that we get a C-frame of a bone is, I think it's bone dot world C-frame. Right. Okay, I think that's what we want. So these are static parts, and then where did our non-static parts go? Maybe those did not get a parent. Oh, they're also called static. Call them that. So if I move one of these, oh, okay, well, they're still not there. Maybe the spring, let's turn this one off. mental loss here. Oh, they can't collide. Maybe they're falling through the base plate.
I swear we should have a drinking game in this seminar. Unanchored parts falling through base plate.
Yeah, okay. It'll be that, and how many times does it take to C-frame something correctly?
Right.
Okay, now let's try turning on our spring again. Huh. What did I do wrong? Let's see. Limits enabled. Oh, okay, that seemed right. Okay.
That's pretty cool.
All right. Let's see. Okay, what does it look like if I... It definitely stays with it, but... Oh, okay, this is pretty silly. There is a constraint whose express purpose is what we're trying to do, and it is the align position. And then let's see, what do we... Oh, right, we need to give it an attachment. Okay, so we'll give the align... want it to align to attachment 0, which is the static attachment. And then the attachment that we're doing the aligning is attachment 1, which is just the part attachment. And then let's give it some force. Is it a vector 3? Oh, max force, okay. So we don't want a spring anymore. Oh, I think I missed... Oh, now where is it? I think I missed reaction force. There it is. Okay, so that did exactly what we wanted to do. All right, we have our force. We have... All right, so we have the align position with vector force. Good. Next, let's see. We're going to need to apply a force per bone. So let's loop through all the bones. Or really, it's not even a bone anymore. It's like a tubule of bones. Whatever, we'll call it a bone. And what now? So let's start with the easy case of the force being just directly to the vacuum and proportional to the reciprocal of the distance squared. So let's get the vacuum position. And then the bone position. So, okay, now this is really confusing. And then world position, sure. And then the distance will be the distance between vacuum position and bone position. And then we'll set, right, so we also need our force. And then we'll do force. So we're going to force it in the direction of the vacuum. So vacuum minus bone position dot unit, and then the magnitude of this will be 1 over the distance squared. And then maybe we're also going to want some scaling factor. So I don't really know what to put here, but let's keep it there for now. Sure, what does that give us? Maybe we'll turn off the align position. Oh, okay. Oh, the vector force is not enabled. And the force is way too small. Where did it go? That was interesting. What if instead of using the force, we just use the aligned position? I wonder how that would look. So maybe we need two. We need one aligned position that wants us to stay put and one that wants us to move towards the vacuum. And then we'll change the max force based on the distance. Does that make sense? Maybe. We might not get a satisfying answer in the next 10 minutes. That's kind of cool.
Oh, nice. Why? Why do they actually go back?
Oh, okay. I don't think the red part was doing anything. I think the cube was just pushing it. Wait, what? Wait, what is happening? Oh, it's because the cube has the bones. We can't see. Oh my god. Okay.
I see.
We need to attach the bones to. Okay. Now I get why our vector force was not working either. But I kind of like this way too. So instead of the bone, we want the part. Okay, yeah, this makes sense. And then we want to C-frame the bone to the part C-frame. See how that looks. Oh my god. Okay, that's horrifying. It kind of works though.
I think that's fine.
Yeah.
I guess the lighting is something you want to somehow deal with, right? Well, maybe not.
Yeah.
Maybe if it's fast, it doesn't matter. Just kind of looks
Is there
cool.
like a cast shadow property that would fix that?
I know what you're talking about. Okay. Oh, okay. I think cast shadow is that's cast shadow. All right. Oh, what it could be is that our cube is shaded flat, whereas we want to shade it smooth. Um, maybe. So we're not getting all of it. We're only attracting some of it. Let's see. What if I just did over distance? Okay, that's a little too much influence. Let's see. Oh, I'm not sure how to balance. Oh, sorry. Go
Maybe
ahead,
you want
Billy.
it to be only the bones on like one face, like as in the face which is closest to the source, and the other one stay put.
I see. Well, I guess if the others stay put, then you don't get like the full object being sucked in.
Right.
It's so satisfying. Okay. Actually, I'm curious what happens if we go back to the original plan with the vector force, now that we actually know how to use it. Oh, well, I can still keep that. That's fine. Oh, I have it up here. Bone pose. Part pose. Force. What did I call it? Nothing. Oh God. Huh. All right. Better luck with the other method. We're coming up on time here, so probably not going to have a nice solution, but I hope at least my little Blender tutorial was helpful in that uh, we all understand how to use bones now. Okay. All right, sure. Let's leave it there.
Now, how can we do this to player models?